Okay, so around 8 months ago, I discovered a video from a huge trading YouTuber, Rayner Teo, who was presenting a trading strategy with a high winning rate, and I thought it would be interesting to backtest the strategy, in specific the winning rate, from scratch with Python. This video is one of my most viewed videos, and I figured it's worth to do some necessary amendments to the first part, which was recorded rather quick and dirty. So what were the main problems with this strategy and also my code? The strategy's problem was there were only a low amount of possible trades over a long time horizon. I've already accounted for that in this video here, where I applied the strategy on all individual 505 S&P 500 stocks. But the main problem in both videos was that we entered multiple trades instead of holding one position, and this is what we are accounting for in this video. We are also using some libraries this time to have less code and taking a look at measures beside the winning rate, such as the net and average profit of the trade. So let's take a look at the strategy again. So we were trading the S&P 500 index, and we were entering a trade when two conditions are fulfilled. First one, S&P price is above the 200-day moving average. And second, the 10-period RSI is below 30, and we are buying on the next day's open. We are exiting the trade when the 10-period RSI is above 40 or after 10 trading days, and we are also selling on the next day's open. That being said, let's get into coding. As you see, I already imported some necessary libraries, which are pandas for data handling, Finance to get asset prices from the internet, TA for calculating technical indicators such as the SMA 200 and the RSI, and NumPy for some conditional checkings. So you can install the TA library by typing in pip install TA, by the way. Okay, so first of all, we want to just pull price data for the S&P 500. We can do that by using the download function from Finance, provide the ticker symbol for the S&P 500, which is GSPC, with a caret in front of, and we are starting in the beginning of 1996 as Rayner Teo is also starting, right? So let's execute that. We're ending up with a data frame like this. You already know this structure here, right? And now we want to just calculate our technical indicators. So we are starting with the SMA 200. So I'm creating a column here, SMA 200. And this column is calculated by using the TA library, then use the trend functions and access the SMA indicator calculation. This function needs an input, which is the close column of our data frame, and also a window, which is the 200-day window, as we want to calculate the 200-day moving average, right? So let's execute that and let's take a look. And now you see we have calculated the SMA over 200 days here, as simple as that. So NAN values, because we are not getting any values for the first 200 entries, right? Next up would be the RSI calculation. So same concept here. I'm creating a new column, RSI. Use the TA library, then the momentum functions, then use the RSI function, provide the close column again, and provide the window as 10. Right? So I'm getting a RSI value here, right? Or an RSI column rather. Okay, so next one is creating a new column which is containing the signal, and the signal is just when both conditions are fulfilled. So the close is above the simple moving average, and also the RSI is below 30, right? So I'm creating a new column here, signal. And now I'm using NumPy, and I'm using the where function from NumPy. And the NumPy where function is just checking for a certain condition, and then it's doing something. And this is what we are going to do here. So we are providing the first condition here. The close price is above the simple moving average. And also, the RSI is below 30, right? And now after the comma, I'm just providing what I want to have. If the condition is true, I just want to have a true value here, right? And if that condition is false, I want to have a false value. As simple as that. All right, so I'm ending up with the signal column here containing true or false. So true when both conditions are fulfilled as said. Alright, now let's find the buying and selling dates. Therefore, we are looping over the data frame, check for the signals being true, and then we are applying our selling logic. So if the RSI is above 40, or if that's never the case, we are selling after 10 trading days. So let's do that by creating two lists first. buying dates and selling dates. And now we are looping over the data frame, and we are looping over every row in this data frame, right? So we're just taking the length of the data frame. And first of all, we are checking if the signal is true by using df.signal ilog I. And if the signal is true, we want to append to our buying dates list, but we want to append the next day's open, right? As we want to buy on the next day's open once the condition is fulfilled. So we are using ilog I +1, and then we are taking the name, which is nothing else than the date here, right? And now we are getting to the interesting part where we are applying the selling logic. And from the point on when the buying signal is true, we need to start another loop, which is looping over the subsequent 10 rows, right? And it's checking if within the subsequent 10 rows, the RSI is above 40. Otherwise, we are selling after 10 days. So let's do that. Let's define the inner loop here for J in range. We're taking 1 to 11 here, 11 because the 11 is excluded. So we are just looping from 1 to 10 here. And now we are taking if the RSI, and again, ilog, and now we are taking I. So we are from the buying date on plus the inner loop, so plus J. So in the very first iteration, we would just take the next day. In the next iteration, we are taking the day after the next day and so on. And if that's larger than 40, so if the RSI within the next 10 trading days is larger than 40, we want to append our selling dates. All right. And we are taking again ilog, then take I plus J, and again +1, because we want to sell on the next day's open, right? And again, we are taking the name to append the actual date. And if that's the case, so if the RSI within the next 10 rows is anytime larger than 40, so if we are appending a selling date, we want to break the loop, right? So if that is happening in the first iteration, we want to break the loop. So then we don't want to check the next n rows anymore, right? Okay, and now we have to account for the fact that this is never happening. So we are taking elif, and we are just taking the iterator, or not the iterator, but the element in this iteration is 10. So in the very last iteration, we are appending to our selling dates. And again, we're just taking this same logic here. All right. So again, this is checking for the RSI being above 40 within the subsequent 10 rows or the subsequent 10 days. And this is just accounting for the fact that the RSI is never above 40 and we are just exiting after 10 trading days. All right. Okay, so we can execute that and have our buying dates and selling dates. And to make this a bit more presentable, let's put them both in a data frame. So let's create a frame here, use PD data frame. Now just define one column as buying dates, and we are taking the buying dates for that. And same for the selling dates, naming the column selling dates and take the selling dates for that. All right, so with that, we are getting this frame here. Now let's take a close look at this frame. And we are running in the problem, which we had in the last video, right? So as an example, we entered the trade here at the 1st of April 1997, right? And we were selling at the 9th of April. But we are entering the next trade here because the condition is still fulfilled. And we don't want to do that, right? We want to only enter this trade and exit that trade and then open up the next trade, right? So let's see when would be the next one. by just printing out the head of this data frame. So this one here, right? The 1st of April, and this being closed the 9th of April. So the next valid trade would be the 14th here, right? And how can we achieve that? And I find this a pretty interesting question. So of course you can also apply that in this logic here, right? But I think the way I'm using in the next step is, yeah, better than that, because this also already is, yeah, a nested logic here, and it's better to do that than the next step, at least in my opinion. And how can we do that? Well, we could just check if the selling dates are below the buying dates if we would shift all these rows by one row here, right? So as an example, for this trade, if we would have this date here and check if this is larger than this value, or rather this value is larger than this value, then we would enter the trade, right? And with that, we would exclude all the trades which are within this time period here, right? So let me show you what I'm talking about. So we could just check frame buying dates are larger than frame selling dates, and as said, we are shifting that by one. All right, and with that we are getting a Boolean mask here, right? So we could check the frame now, and as you see, now we are getting only the buying dates which are not overlapping, right? So we only have one position open here, right? You can see that here, 1st April, 14th April, and so on. So what you might have noticed when taking a closer look, that we are excluding the very first trade. So we have to account for that as well. That is due to the fact that when we are shifting this column, the very first entry will be NAN value, or an NAT value to be more specific. And we just have to manually append the very first row to the final frame, right? But anyhow, let's call that actual trades, right? And now let's just take the very first row. So this one here, this is our very first trade. Let's just append the actual trades to that. And with that, we are also getting the very first trade, right? So, and then let's just reassign that to actual trades. All right, so let's take a look again. And now we are getting all trades here, right? Without having overlapping positions here. So you can check, you won't find overlapping positions. All right. Okay, now let us calculate our profits, right? So yeah, let's just call that profits. Let's go in the next line because it's taking some syntax here. So how can we get our profits? By screening our data frame, use the log function, and then just use these actual trades, then the selling dates, and then the open price, because we are buying on the next day's open as defined in the beginning, and then we're just taking the values and we are subtracting the buying prices, right? So selling price minus buying price is your profit, right? So we can just copy paste this logic and replace selling by buying dates, and that's it. So I hope you can see that. Yeah. So let's execute that and let's take a look at the profits. And now you see these profits here. So yeah, I mean, you could take the mean profit, but I would rather calculate the relative profit first. But we could also check for the winning rate here, right? So we could quickly check with the list comprehension I for I in profits. If I is positive, then we have our positive trades here, and then we could take the length out of it. So we have 34, and we could just compare that with the length of the profit. So we have 34 divided by 36. So we have a slightly higher winning rate than Rayner Teo, right? So now let's take a look at the relative profits. So I'm just copy pasting this syntax here again and do some amendments. So let's call that relative profits. And now the only thing what we have to do is we have to set this equation in relation to our buying prices, right? So we can just copy paste this one here, set that into parentheses, and divide that by the buying dates again, right? So just our relative profits. All right, so let's take a look, and here are our relative profits, and we could take the mean out of that, which is 1.35%, which is close to Rayner Teos numbers, right? So there are some slight differences, probably due to the RSI calculation, but these numbers are very close to Rayner Teos numbers, right? So we have this profit per trade, we have this winning rate, and now I think one of the top comments was your net profit was negative. A cool story, mate. By the way, this is not my story, but Rayner Teo's story. But nevertheless, this comment might be true in regards to the video I've uploaded, but it's not true in regards to the strategy, because if we're taking a look at the net profits, we can do that by just taking a look at the cumulative returns. And therefore, we could take our relative profits, add a 1 to that, and take the cumulative product. So I won't go into details here. I've explained that in another video on my channel, how to calculate cumulative cumulative returns. And if we are taking a look at that, we are getting a net profit of 61.63%, which is very close to Rayner Teo's number. So I think he got like 65%, right? So if you want to have that in absolute terms, you could take 1 million times this one here, and then you're getting the amount what you would have made out of 1 million US dollar or whatsoever currency, right? So we have $1 million, 616 something. Of course, you can do additional stuff here, right? You can calculate the average profit, the average loss, the maximum drawdown, and stuff like that, right? So maximum drawdown, by the way, is only 2% here. So yeah. Anyhow, now let's construct a strategy in such a way that we transform our code into functions to make it work for other inputs here, right? So to make some functions out of that, we could first of all copy paste this whole stuff here and create a get signals, or get actuals function, which is taking a data frame as an input. Then just copy paste the code here, taking care of the indentations here. Okay, and now we are doing the stuff I did above here, so transforming that to a frame. I can just copy paste that here. So this one, let's quickly code that. So we're just taking the frame of the buying dates, which are larger than the shifted selling dates. And then we are using the very first row here, or other way around, and append the actuals here, and we are returning. Oh, I messed up here with some indentations. Now it's fine. Return the actuals here, and with that, let's test that out. The get actuals here, we could use that on our current data frame. Get actuals. Blind. Actuals. And get our trades here, right? And now you can provide any data frame on that. Of course, you also have to do the technical calculations. So let's quickly do that as well. So TA, calc, df, and then we're just taking the technical indicator calculation from above. So this one, this one, this one. Can I copy paste cells? Don't even know that. Is it possible? Nice. Okay. Now we're just doing the technical calculation here. What happened here? Okay. Okay, this is the technical calculation. Yeah, we can use it like so. Alright, so we have to do one more amendment in the other function. That is limiting the loop range here by 11. 11 because this is the maximum we can get out of the range, right? Because we are adding up a j here, which can be at max 10 and also 1. And imagine you have a buying date, a most recent buying date, for example, in the very last row, then you would loop out of this range here. This is why we have to amend that. So let's actually execute it again. And now let's play a bit around with this, well, with those two functions by pulling the Bitcoin price, BTC USD. We're just starting, I don't know, beginning of 2010. And now we can apply the TA calc function to that and get the buying and selling dates, right? And now to get the profits here, we could just copy paste the logic from above. So where do we have it? Relative profits here. So let's actually just assign that to actual trades. I mean, you could also write a function for that, right? To improve that, but as always, there's a lot of room for improvements here. Okay, this should work. So let's take a look at Bitcoin. Pretty juicy trades here. Also huge drawdowns, 15% here, but also a nice trade of 28%, 29%, 14%. So Bitcoin, yeah, decent 4.7% over the last 10 years on average on each trade. But let's actually test that for the whole S&P 500, right? So we are creating a matrix of profits. Then we need some tickers first. So we are just taking the S&P 500 tickers. So I've covered that in my 70% winning rate video, which I will link in the video description. I'm not going into details here. So I'm just copy pasting syntax. This is just getting the ticker symbols from Wikipedia. Then we want to transform the symbol column to a list. And we have to do some amendments to the tickers. And with that, we are just getting the ticker symbols for the S&P 500. So these are 505 ticker symbols, right? So this is the only thing you have to understand. All right. And now we are looping through those tickers for I in tickers. And now we are just pulling data for every ticker, right? So we are creating a data frame, YF download of I. Let's start. What can we take? Beginning of 2000 here. Then we are applying our tlcalc function to the data frame. Then we are, let's just keep the logic from above. We're just calling that actual trades. And then we can take the relative profits. Let's take this logic here. And finally, we can append these profits to our matrix profits. Don't be confused with the name, I just didn't find a better name. This is just containing all profits for all assets since 2000, right? So this will take a lot of time as this is downloading the data, but let's execute that. And now we see we're getting 505 downloads. So I see you in some minutes making a cut here. All right, so here we are. We have our matrix profits here. So let's print them out to see what they look like. So you see we are getting multiple arrays here containing all relative profits on all trades here, right? So how can we make sense of that? We could, for example, take a look at the average returns here for I in matrix profits. We have to check if I is larger than 0. There might be empty arrays here. Then we're just, averages. Then we want to append the mean of the array. So let's do that. Length of the array, of course. Okay, so let's take a look what we got, and it seems to be that this is a solid strategy, right? So a lot of positive trades here. I mean, you could even take the average of those averages here. That's positive. Should be a good sign, right? Does the list have a max function? Yeah. Okay, max is even 11%. For what? Quickly check. Interested in that. So what I'm doing here, sorry, this is spontaneous here. So I just wanted to know what is the best asset with this strategy from the S&P 500, and I was taking the maximum of those average profits and then just index for that, and now I can index the tickers and find the asset MAA. It's MAA. Mid-America Apartment Communities. Okay, interesting. But anyhow, I think this strategy can be even improved, right? So you could, for instance, you could limit the losses. You could, what I would find interesting would be to apply another exit. I mean, why should you exit after 10 days? It really doesn't make any sense for me. I would rather, instead of defining the exit in relation to the RSI or dependent on the RSI, I would rather apply, for example, a trailing stop loss mechanism. I've done that on one of my crypto videos. So if you are interested in diving deeper into the strategy, just leave me some feedback, leave me a like, leave me a comment, something like that. And as always, be invited to let me know what you think in the comments below. And I'm looking forward to seeing the upcoming videos. I hope this was adding value for you. I hope this was interesting, and I hope I could yeah, clear your doubts on the last video. And yeah, thank you very much for watching, and see you next time. Bye bye.